I could have got that a lot quicker.
The first one, we are going to introduce you guys, and we're going to tell you about our experiences with various bits. So John will do a bit, I'll do a bit, Dave will do a bit.
Yeah.
I will put the images over the final video because I think it's crisper rather than having a video on a PowerPoint, which is a bit glitchy. We will then, once we finish that, we'll end it, and then we'll do another one where you guys can then start saying, this is some of the new products we got, etc., and just talk about any earthing issues we have.
All right.
Okay. Sounds good.
3, 4. Right. So shall we just kind of wing it?
Yeah, let's do it.
Wing, 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 wing. Hello, everybody, and welcome to another E5 podcast. I am your host for today's session. I'm Paul Meenan. Thank you for joining us. And I'm joined, as per usual, by my colleagues and friends whose phones are bleeping in the background. My tag team partners. Chaps, introduce yourself.
Hello, I'm JW. And it's David Watts here, Sparky Ninja, turning his phone to mute.
Yes, indeed, turning his phone to mute. In fact, I should do the same thing. And we also have some guests on. So they're semi-regulars, but let's welcome back Earthing Services. Gents.
Right. So good day to all. My name's John Mayer, Technical Director of Earthing Services UK Limited.
And I'm Sean from Earthing Services.
Welcome. Now, it's not the full Brady Bunch today, but we might do that a bit later on. Who knows? We've always got lots to talk about on earthing. So I've kind of almost lost track of the amount of stuff that we've done on surge. We've got more to talk about on lightning, and earthing is key to everything. Earthing is key to safety. So what we did in our last podcast, we talked about the Conducdisc and your company and your behaviors and your corporate stuff, which is really good, and some of the possibilities. But it's best to come onto these podcasts and walk the talk. So since that last podcast, I have installed the Conducdiscs as a trial. Mr. Ward has, and some of our industry colleagues, Richard Emery and co, have also done some trials. So what we wanted to do was get you on here and not do a Spanish Inquisition, but actually give you feedback. So Dave, do you want to start off the feedback sessions?
Me? Yeah. Well, I took a disc to my old man Father Watts because my area of interest was, are they going to be that good for events? Are they more practicable and safer to install with events? We've had a couple of little exercises with them and a couple of little tests, and they, you can pretty much just put it on the ground and pick up a good reading anyway. But good friend of ours, Dickie in the Discord, who has actually been more active in using them, has sent me some of the information he has got, and he has basically said that when he put a disc down on the floor and just stood on it, this was at an event which had a very, very thin soil level, then quite hardcore course underneath. He just put it and stood on it, and he got immediately 150 ohms just by standing on this thing. He then buried it to a depth of 300 mil, and he got 75 ohms. Now, from the perspective of events, there's no Conducrete, there's nothing else there. We have just literally just borrowed a little shallow well there into the ground safely, no spiking, no nothing. And we've just gently topped over this disc. 75 ohms, which means from the perspective of events, we can easily get a 500 milliamp hour CDI Delta Rain on that, which is great for selectivity coordination because we want the highest RCD we can get on events as the primary RCD because we don't want any silly tripping events. So very good initial approach, and he's actually going to be doing an awful lot more looking forward, and he's basically taking it as his default for it, and that is just that's not using any of the other products. That is just a disc in dry ground as a safer method of earthing, spiking, and that's just proof on the testing there. If we can get in events RCDs higher, over 100 amp, if we get 300, 500, or even 1 amp, brilliant. And you can easily get a 500 milliamp RCD set with that value. So very, very good results on that.
Super.
Well, if I may just check, I mean, these events that they're going on, presumably it's just, it's a temporary system.
A three-week temporary, the one he's done this on.
So at that point, the disc gets to be dug up and then
he reuses
it again. Great. Now, that's wonderful to hear. Now, I know that might seem strange for someone who sells these things to say, great, you've bought one and it keeps going on and on and on. But that is surely a better value prospect. And if it's better value, it's going to be used, it's going to be safer. It's been great. Fantastic.
I think what my brain is telling me is from a BS 7909 application, this is 7909, nice and simple, and sustainability defined.
And safer.
I can keep picking this up moving it around. Hello, let's be honest about it. I know a lot of guys who've done temporary installations and they've driven a rod in and they can't get it out, so they just kind of keep whacking it till it disappears and it just stays there.
Just yeah.
Oh, yeah, usually it's an angle grinder, just slices it off at ground level, and then, you know, put a few leaves over the top, and then it's not your problem anymore.
So it's another positive then, which is great. Dave, do you have any more examples?
Nothing direct, but we do have. Do we have data from Richard Emery? Do we have the data from his work? If not,
and I'll find out.
If not, you can look at his stuff on Instagram, because he has done a farm of discs, hasn't he?
He did
and product, and he has tried to get an earth value very low, and he's been very happy with his results, I think.
Well, yeah, I had a chat with Richard, and the final resistance was in the order of 0.6 of an ohm. But when you consider that is sat over chalk, and he says around the site he's got quite a few earthing systems, and I think it's fair to say that he was surprised with the result.
Because he's getting the first weldings and all sorts done, wasn't he? It's a very, very good effort at, you know, dictating what your earth will be. A lot of us think, oh, we'll put the rod in and see what we get and try to work with what we get. But you can actually say, no, I'm going to get this. And he's just engineered it that way. So I'm hoping to kind of collect some images from him. I mean, he's a lovely bloke, and he's offered me to go and have a look see at it. It's just something we've not had the time to do yet.
Richard,
but it's a great case study.
Richard's a lovely bloke, and what I'll do is I'll try and put some images on this screen in front of what he's done. I'll ask his permission to do it. But what did you say the reading was again?
0.6 of an ohm, or just slightly 0.6 something
of an ohm.
I did look at it yesterday,
and that's a big installation. Richard's doing a lot of big high power HV distribution around a very private estate. So that's good. That's well within TNS region.
I think you're looking about temporary earths. A number of years ago, in a previous life, we were tied up with a company doing these temporary sites from Silverstone, as an example, point case, that all the telephone companies there, and there's 150 plus thousand trying to use a mobile phone, possibly at the same time. And events like that, and even concerts in quarries, which was also extremely challenging. And the Conducdisc, it is ideal for situations like that. But as you said, Paul, earlier, at the end of the event, they were just driven out of sight. So there isn't a trip hazard for anybody.
Do you know what you've just made me realise the Conducdisc actually is? And this is going to sound really corny. It's like a plug socket into the earth.
Yeah.
For an earthing system.
Yeah.
Plugging into the earth with a disc rather than driving it in and offending the earth and potentially going bang. That's how my brain's gonna picture it.
I think that's a really nice way of looking at it, and I don't disagree with it. It's kind of somewhere between what you've just said there and then what Dave was saying a second ago. There are a couple of people that I won't name, but I know that on some of their events that they've done, they literally have placed the Conducdisc on the floor and then driven over it and just left the tire of their van on top of the disc. And, as far as they're concerned, they're getting the resistance. Again, I'm not endorsing it, but in terms of the resistance level, it's achieving the what they require.
Yeah, it's like a black hole into low impedance.
Well, a black disc.
Sorry, it's a quote. Just to be clear, by the way, we're not being paid to do this, and we're not sponsored. So we've actually done this on real world installs. So what I'll do, if it's all right with you, John, because you're the domestic market, I'll tell you about my one. So obviously, me being a cynic, I like to hear good things and positive things. So I thought, okay, at the time of the last podcast, we had a certain station in Essex where there was an earthing challenge. So what we decided to do was get a earth farm done. Why put one rod in when you can get a nice farm, a general overall low impedance, makes the installation safer. So we designed an earth rod farm, just all connected by tape. And then obviously I came and chatted to you people, and you introduced my mind to these black holes into the earth, a better way to plug into the planet. There's another, that's copyright me. Um,
Okay.
Take note, Sean.
yeah, take notes. But no, it is. So I decided, because I'm in charge and I can, to change the rods to the discs as an experiment. And it's the first time they've ever been used on UK rail, as far as I'm aware, for a railway station. And so the original, we did soil resistivity testing and all that, and all informed the design. I got a full design pack, so creating baseline data. And we designed the earth farm for about 1 ohm, 1.1.
Yeah, thereabouts.
And then we changed it to the discs. And we installed the discs, and that was a fun experience in itself, watching them being installed. And even the guys installing it loved it. We had John come down and line us all up and brief the troops. And it was a fascinating experience. Now it's it's on. We've got a main RCD and all that good stuff. So every 4 weeks, as many people know, I go out and I test it because I'm trying to get a comparative
Over time.
understanding over time. And I use it as a perfect opportunity to practice some CPD in doing fall of potential testing. So when I'm out there, I do the full 10%, 20%, 30%, the whole profile of the run. So I take earth electrode measurements. I'm moving my voltage probe. I then do the stateless test with the 2 clamps. And I also do ZE and ZS. So I do the full suite of tests every 4 weeks. And occasionally some people come down and we go through it together as well. But I've got on the electrode farm itself 0.6, and the highest it's measured was 0.69. Okay. Now this is where it gets even more funkier. When I've done the ZE testing, okay, what was it? The last test we did was 0.36 on the ZE test, which is mind blowing. Absolutely, when you're chucking a real fault current down it. And then on the the ZS test, it went down to about 0.29 on a real world ZS test. It's off the charts, man. I've got my own TNS system, and it's pretty stable. The interesting bit will be during the summer, but as it's performing, it's exceeding expectations beyond belief. And if we can maintain that stability.
So if you can get a guarantee that you don't have any value over, the values of a TN equivalent, you could actually remove your RCD.
So here's a challenge for the whole industry, and this is an open idea. I would love to see, and I mentioned this to Schneider about 7 years ago, I would love to see a device that mounts on a board somewhere that's basically capable of doing an earth loop impedance reading, a consistent one, or one every 30 seconds or 60 seconds or whatever. Now, I know everyone's moaning it's expensive. No, it wouldn't be. The electronics and stuff would be relatively small. Thanks for yawning, doggy. My dog's yawning. You're bored of this already, aren't you, dog? Go away. Go back to sleep. Sorry, we're live. What can you do? No, we're not. So what I would love to see is something that consistently monitors that ground impedance and is able to collect a year's worth of data, mainly for TT applications or for 7909 applications. But what it would do is it would give you a really good level of confidence that the earthing systems have a level of stability or not, and what risk treatment you need to give. Now, we have micro technology, Internet of Things stuff. You can't tell me that 2 sensors, some fuses, and a little DIN rail mounted device with some connectivity couldn't do that automatically. So I'd love to ask everyone in the industry, go and make one. I'd use it. I think there's a market for it. Build it into your panels. Dave's sitting there cursing now. He's closing his eyes going, "What are you doing, you scumbag?"
I'm just taking a note of something in my mind.
He's taking a note of something. Sorry. So there you go. Free idea. And yeah, that's it. That's a challenge to the whole industry. It's my opinion. Now we'll go on to you, John, because you've done a domestic install, haven't you, sir?
Yeah, well, kind of, yeah, because it's one of these partially domestic and partially commercial on the same site kind of situations.
Yeah.
But yeah, it's a farm, it's a vineyard actually. It's good, isn't it? Luxury. And anyway, it's a site. There's an old building there, which is basically a farmhouse which they live in, and then they've had a new building constructed for business purposes. It's a TT installation because it's in the middle of nowhere, and the transformer is literally on a pole across the field somewhere. And existing, it's got 2 manky old metal earth rods put in. They measured sort of in the region of about 150 ohms, which is not too bad. I mean, it's still okay. It's certainly not very good. All on RCD, obviously. This new building they had put in 1 disc at the back with some of the concrete as well. When that was put in, it measured about 20 ohms, literally just after it had been put in. So already that's dramatically better than their 2 earth rods at 150 ohms across the other side. And then subsequently went back several weeks later and we got down to about 16. So it was actually reducing over time after it had been installed for a while. And that was just a single one put behind the new building in a hole which somebody else dug, thankfully, because don't dig holes, do we? Because who wants to be doing that? So it was about 2 feet down. The soil there is a bit variable. It's sort of mixtures of clay type stuff and other stuff because it's all been dug up for farming purposes over the years. So last time we went there, it was about 16 ohms just for that one disc, which obviously is massively better than the manky old 150 ohm rods they had near the front. And of course, the main point is that it's not going to rot and corrode away because the 2 rods they had, one of which was pretty old, was not in a particularly good state, and it was one of these where it was actually sticking out of the ground by about 6 inches in some shrubbery, and so yeah, not exactly ideal there. And loop impedance on the whole thing when we finished came out to be about 22, and that's partly due, obviously, there's some other earthing thing back at the transformer on a stick in a nearby field. So just one is dramatically better than even 2 of their existing earth rods, and of course it's going to last for hopefully decades without any maintenance, corrosion, or anything else. So we do have a picture to this which we can fit in here later. So
Muted, Paul.
Sorry, I'm on mute, aren't I? Sorry, my dog. They will have magically appeared on the screen, John. So don't worry. Well, using the magic of the software, we'll put some images over it. But yeah, it's do you know what? The cynic in me was hoping, yeah, all right, yeah, we might get these have blown me away. They've blown me. They have performed brilliantly. And if anybody has used one of these and it's a bad test, let us know. Put in the comments. I'd love to see if someone has. You've probably installed it wrong. Let's be honest about it. But
upright on its surface.
Yeah. We'll put it on its side on the ground on a bit of concrete. Probably won't get a great reading there, but you never know. I'm sure.
Yeah.
Lots of stuff.
I mean, we
do
do recommend you take it out of the bag before you install it.
Well, the plastic bag.
Right.
Yeah.
I knew I was gonna
But we do go and say that I say to anybody that we talk to regarding the Conducdisc that it sounds as too good to be true, but on the day of your install, give me a call. I will talk you through it, and it just gives them that little bit of reassurance. And I think out of literally hundreds of that offer to people, I've had perhaps a couple of people come back to me and literally talk them through over a few seconds. And then I can't believe that. It is as simple and as quick as what we say it is.
It's just on that. I think the key thing you said there, John, is you will talk people through it. So word to the wise, listen to what he says and do it. So one of the key things for me from an installation, lessons learned, compression is key. Now we put I think it was 8 discs connected with a bare conductor with Conducrete, which is all good. But the minute that's down and that cable is covered with Conducrete, get your muck on it and get it compressed as quick as you can. The sooner you get the muck covering it, the sooner you get that compression, the sooner it can all compact and bond and bind, and you get a far better reading. And that's really key. Don't ever leave a trench exposed for Conducrete to dry to atmosphere, because you're going to get one side really good and the other side a bit poorer. So make sure compression is key. I just wanted to flag that as a lesson learned.
Yeah, by putting the partial reinstatement of the excavator material, place it carefully over the drop powder, and then you'll see it will immediately solidify. You know, so much so that you can walk on it quite evenly. In fact, as I say, as you said there, Paul, the more pressure, the more effective it will be.
Yeah, because what we're talking about is a method of moving electrical current. You know, it's transferring the energy from this media to that media, or medium to that medium. And the partial reinstatement is doing exactly what you said, Paul. It's getting that binding process commencing. So instead of them sitting like, two different elements, they start to enmesh. And that means that the actual moment of discharge, where the current is passing from the conducrete into that surrounding mass, it's a far easier flow. They've not kind of got a resistance against each other. So,
just like any connection, you want the best transfer of energy, don't you?
That's exactly right, Dave. And I think that's the lesson. Get it reinstated. And there's another really practical reason to get some stuff on top of it quickly, and that is that it's really fine. It's a fine, like almost talcum powder like consistency. So if you're leaving that as dust, then you
blow up.
Exactly that. It will blow up, or even with PPE, it's going to start getting into your clothes. It might not be. It's not a fashion issue, but all the amount of conducrete that's in your clothes or in your PPE, because you've not got that layer back on, it's not doing its job as part of your own system.
I think, if you don't mind me saying, once you've got your base layer in, you've got your bare conductor or whatever tape you're using, it's a matter of just synergy of the installer to get your bag of concrete. As you're pouring it, there's a lad with a shovel and he's backfilling it straight away. That's the best way. And don't drop it in the hole. Gently drop it in the hole, then compress it, because you don't want to drop it into a 600mm hole and have it all plumes of dust. It's managing the material in the trench is another very important, health and safety, but also just getting the maximum out of the material you're using. It's really important.
Yeah, you're paying for it, so why would you want it in the air? But moreover, it's just that slow and steady reinstatement for about 50mm. As long as that powder's covered down, just boots. I mean, if you've got something heavier, then great. But just walking up and down on the stuff, that is going to commence that compression process. It's really easy. I mean, this is part of the way that we develop these systems, is taking that complicated method out of it. So it's empty the bag, it's putting a disc in, it's standing on top of it. Try and keep it simple, but by doing so, in a very short amount of time, you're achieving quite a lot on an earthing performance.
Well, I've got a bit of a case study, right, where it was a grade cabin at the side of the road. It was installed in Ipswich, which the underlying ground was gravel. So the existing earth was 125 ohms, and they were looking for one below, less than 20 ohms. I said, you take that protective ducting out for the extension to the earth system. We can't do that. How are we going to protect the cable? I said, you will not need it. Anyway, we did the modifications. We put some conducrete over the bare cable. The resistance dropped down to 16.5 ohms, so below 20. Very, very happy. And I said it will continue to reduce resistance up to 28 days. But do not worry about the protection of that cable. Anyway, 28 days later, we're back down in Ipswich. Check the resistance. It had dropped down to, I think, about 11.25 ohms. Very, very happy. And then he turned around to the guy with the spade, dig it up. Right, he wants to see that cable was protected. And the lad was doing very, very well till it hit the concrete. He nearly broke his wrist. And I was surprised, not about not breaking his wrist or breaking his wrist, but when it was exposed, the concrete had flattened out to the width of the trench, which, it was first time I was actually seeing it, because we normally put it in a hole and it works and we don't need to dig it up. But anyway, that just proves that it does bind and it goes that hard. Don't try to dig it up.
Well, yeah, because again, part of it's dispersing energy. There is a kinetic element to that too. So if you're going to whack it with a pickaxe or a shovel or something like that, then it's still going to be throwing that energy back out. I mean, I can send the reports over later, Paul, if you do want to show any of these pictures. But literally an exposed cast conducrete conductor that's been attacked with pickaxes and sledgehammers, which was part of some testing that we had done on it. And, it's robust stuff. It doesn't want to go away once it's there. So
fit and forget.
Yeah, fit and forget. I mean, it's really nice to hear these stories. I mean, they're far from unusual for us, but one thing's for sure, it's never nice getting bad news, so it's always nice getting good news.
Yeah, for me, it's kind of proven to me. Don't worry, somewhere in the world there is a use for rods, but for me, the benefits. I think we said in theory the benefits were great in the last one, but the practicalities of I'm now going out every 4 weeks and measuring the resistance of these electrodes, and there's a notable drop over time, and it's increasing the safety of the installation. And just while we're on that, 20 ohms is, to me, as we've been researching a lot recently, it's a really important value, isn't it? The more you read up on it, 20 ohms is if you're above 20 ohms, you want to maybe possibly have concerns. 20 ohms seems to be a safe figure to protect people from nasties that could occur in networks and stuff. So yeah, I mean, I think we've all exceeded expectations. Guys, is there any more feedback or suggestions or comments on this one? Because this is always going to be a quick one. We said we'd do a feedback review, and we're doing it.
I think it's just more examples we can see of people using it, showing the benefit, engineering earthing instead of just spiking and hoping for the best. More of that we get, the more of the examples that we can see, and then the more we can actually, use that, the more that electricians will be understanding the value, because without a doubt, there's more of a cost between one option to the other. And so most will go, well, why should I switch over now when I have this, and how do I talk? How do I explain to customers why I want to spend so much more on it? But with the information and the actual understanding on the benefits, the life benefit, as John expressed a minute ago about that with the vineyard and the poor condition of the rods, the maintainability, the future proofing, the life cost. I think over the next, I did an electric vehicle car charging course not long ago. The tutor hadn't even heard of them. No. He was all about new technologies, and not liking spiking because of the danger. I said, what about Conducdiscs? And he was just like,
what?
So it's just takes a bit more of a time for us to talk about this and show our experiences with this. But I think engineering earthing, electricians putting in the effort to understand what the output will be at the beginning of the project, and it's safer. So it
is. I mean, the thing that, when people are used to using earth rods and they're used to paying a few quid for them, then the price difference is going to be surprising. We are coming up with cheaper methods all the time, so do stay in touch. But there is a big difference. But then it also comes back to, John was talking about it, where were the rods that were sticking out of the ground? Well, that tells you straight away that they'd been installed from surface level. Now, according to the standards, where are we supposed to be installing rods from? We're supposed to be digging down to 600 mil and then driving. So if that's the case, and straight away you've got the time saving point when you've dug your 600 mil down, you're dropping the disc in and you're already at that level. But if you're going to be doing it from surface, you're already, I'm not saying cutting corners, because I don't want Sparkies to hear this and think that I'm just trying to have a go at them, and I'm the guy with the different technology, so that's of course I'm going to be picking on them. That far from it. There are commercial realities to doing their jobs, and I will never dispute that. But what I would say is, if you can educate your clients a little bit, then not only will you hopefully make your life a little bit easier, but you'll be giving them a quality job that they'll be thanking you for years to come. Because those, be it through deterioration of a bare metal system, or be it through improper installation and resistance is rising, it's never nice to go back. It's never nice to find a fault and have to try and remediate it. It's nice to know that you've done the job, it stays done.
And
sorry, carry on.
Sorry, and it goes without saying that maybe not in this next brown book, but in the near future, we're going to start wanting to establish a independent earth reference that is sustainable and assurable, because we're going to have so much reliance on that reference of an earth, with the supply earthing being in such a dire condition at the moment. Sorry, John.
Yeah, I was just going to say that as part of the support that we provide all our clients, we do have an extensive uniform soil resistivity database. So, give us a postcode and we'll find out what the ground conditions are. And then if you tell us what your target resistance is, then we'll come up with a solution. As you were saying, it's an engineered solution as opposed to fit and hope.
Yeah, because I might ring you, John, and say I want something, I don't know, somewhere up in Winterfell, up north somewhere, and you come around and say, well, the soil resistivity is basically just all slate and old coal or whatever, so you're not going to get much. And then you can say, well, Conducrete won't work, but Conducflow may, or something else. And
absolutely,
gives you options. That makes sense. It makes sense. Although I'm going to be controversial now, because
you can.
I'm going to say it as I see it. I think it's inevitable that we will be putting in earthing into domestic homes everywhere to mitigate the poor network and the poor earthing in the network. But when you put a earth into a house and the network is failing, you can mask the whole broken pen issue, which we did cover in our broken pen podcast, webinar, whatever you want to call it. And it used to be that if you put a disc or a rod in a domestic home, it was because it was the end line of a branch, or it was a DNO, regional electricity company requirement to protect the network. If you do it everywhere, you're almost just discharging the responsibility of the DNO to provide a safe earth and making it onto the consumer. And I think that's dangerous because it can mask broken pens. We know there have been instances where plumbers have taken boilers off the wall. The pen, the protective earth neutral supply conductor was gone, and it was effectively the local water and gas pipes that were doing the masking of it. Took that off, 240 volts, shock. It even warns about that scenario in the network standards. So if you start putting electrodes in, is there a potential that possibly could happen? And I'm not saying don't stick them in, but just know how, to quote Dave, engineer your earthing. Consider what you're doing. If you're in a new build, then you're going to have a brand new system, nice new cables. There's an absolute benefit to it. You're at reasonably low risk. It's not a 90-year-old PILT cable with hundreds of joints or more joints than cables. So just be mindful of the network conditions. Start at that intake and look at the state of the cable coming in. That's a risk profile. If it's old, it's a high risk profile. If it's new, you can assume it's a lower risk profile. Standard stuff. So I wanted to put that in fairness of balancing it all out.
Yeah, definitely.
I didn't want this to be too much of a love-in. Okay, but give me feedback.
We can throw some bricks at each other in a minute. No, it's true though.
Well,
sorry to cut across you there, John, but there is that point. You are talking about a known deficiency in terms of that PME network, and I know that you've got that's covered elsewhere, so I'm not going to drag that through. But you've got to be able to make that assessment in the exact same way that if you're relying on the PME or the downstream wiring, you need that neutral not to be broken or whatever. As far as things like OPEN type devices, great.
I don't recognise OPEN technology. Sorry.
But this is the thing. It's the predominant
moment
EV charging networks going, and I don't. I can understand why. I can see the appeal, but if you haven't got that whole understanding of the downstream circuit, where the electric, a fault would actually be discharged and what the condition of that would be, and actually the inline wiring that it's reliant on to be effective, then there is an element of hit and hope in all that. And hope is not nearly as good as knowing. So, that is probably my word of advice to that. Don't just, even if you test it, you see a low resistance, see if you can find out. Talk to the DNO, see if you can get them to tell you the condition of the PME.
Yeah. Well, interestingly enough, when we're looking at high voltage earth systems, we have to go through not only comply with the British standards and the technical specification 4124 E&A, we then have to look at the individual DNO standards. And within that, there is the contribution from the network. Now, not all DNOs give you that information, but it is quite interesting. There will be contributions there, but it's dependent on the size of the network and the ground resistivity.
Yeah, I've always found it weird that the E&A is the voice of the networks and is made up of people from the networks, but then they write standards for their own. It's
for their own.
It is what it is. It is what it is. So just to clarify what I just said about open technology, I don't have enough competence to understand how the devices work, or assurance in the public domain as to the efficiency of their technology. And mainly, as we discussed with our brother Paul the other day, there's no BSEN standards for this, so that's my baseline data to do an assessment of. I don't see much technical or assurance information, compliance with directives, so I'm still a put something in the ground man, and I'm happy to be proven wrong, just for the fairness of this debate.
Yeah, definitely. No, as am I. I think there are certainly better devices than others on the market, if just to see how they've been tested, just to see the hoops they've jumped through. And
well, funny you say that. We'll cover that on another podcast.
okay.
Yeah, I think the interesting thing about the open devices, again, I'm assuming that they operate like an RCD. So to that, there will be an element of maintenance required to check that that device functions as and when it's needed. So, but I haven't seen anybody saying, check the device every 6 months like an RCD.
John, Dave. Okay, John, thanks for that grenade on the table. Mr. Ward, as our residential EV fitter, is there a button to...
No, there isn't. No, the problem with those devices is that there's several different ways that people are making them. Some have more stuff in than others. None of them have any testing features or anything to do it with anything. You just literally are fitting it and hoping it's going to work for however long it's installed. And so, yeah. And obviously it is a mechanical device because it's got obviously some kind of contacts to disconnect it, and it's got monitoring circuits in there to determine various factors depending on who's made it and whatever. So there is no standard for these devices. So literally if you buy one from one place and one from somewhere else, well, they could be completely different.
One without going into too much detail on what we had a discussion with one of our close mates, Mr. Skirm, it's like where software is used to provide protection, there's a whole lot of things needed there which he cannot find trace of.
Well, I'd love to do an impression of him, but my brain...
No.
Safety integrity level, software controls. If it's a safety device, it must have a SIL level. But
so we go, yes, Paul. Okay.
Yeah. No, but he's right. It's when you're developing any product that's like that, you must. So this is an electronic product, so it must comply with the LV directive, supply of electronic equipment regulations. It must comply with the EMC directives, radiated conductive emissions, immunity, all that sort of stuff. I see no evidence that these devices do it. But also there's something called safety integrity level for anything that's safety related that software can control. It has to fail safe. It has to have independent checks. It's quite expensive SIL levels, and the manufacturers have to pay for that. But I don't see any of them telling any of this stuff.
No.
And John has rightly said, it's a big box of things on the wall that makes life better. Does it?
Yeah.
And then you've also got the thing where some EVCSEs have it built in, others don't, and then you can buy a separate box of stuff to go with it, and then you're like, well, it's just a complete mess. So beware, because you've got really no idea what you're getting into there and how long it's going to last or anything else. So, and if it does break, well, who's going to know until something goes wrong and it doesn't do what it's supposed to do?
So John's opinion, it's a big mess.
Yes. There will be further development in that area, I'm sure, because
we'll get to it eventually. Don't worry, it's coming, guys. We're gonna go through these devices with a very fine tooth comb and talk about everything. It's on the agenda. Don't worry. Okay. Unless anybody else has got any feedback, things they want to say, I'm going to end this here.
But I've just got one,
okay.
And that is just to thank you guys, because as you say, we aren't sponsoring you. That isn't something we would do, and it isn't something you guys would accept. But it's really nice when people are sharing their experiences, because we have a lot of clients who have we work with all kinds, from one-man bands all the way to multinationals, but so few of them are prepared to put their name to their experience. And this is one of the problems when people say, oh, I don't know why more people don't know about it. Well, there's two reasons. Either they've got a market advantage not to do it, or they've got a market advantage that they don't want to share if they are using it, and they don't want their competitors to know. So yeah, we've got a whole filing cabinet of NDAs of things we aren't allowed to talk about, despite they've gone very well. So the fact that you've all, you know, taken to publicly saying, yeah, we've enjoyed working with these things, thank you.
Here, here.
Well, you don't have an NDA with me, so
That's true.
And in fairness, the rest of Network Rail are quite interested in these now, because let's be perfectly frank, anything that is less of a ball ache to install ticks a lot of boxes for people nowadays, and it was relatively simple to install a farm, and it's nice to know you're not digging up half the planet to do it. And yeah, so
and from our perspective, we're all about looking at improving things. This is just earthing evolution, you know.
Thank you very much.
trademark Sparky Ninja.
There we go.
I think we have that one actually.
all these one-liners, it's just great. Right, okay, we're going to end on that. So John and Sean, thank you very much for joining us.
Welcome.
JW and Dave, as always, thank you very much. So for everybody watching or listening, thank you for joining us. And until the next one, because we will be back, because we want to talk about what the future holds for earthing. Until the next one, take care of yourself and each other. Bye-bye.
Bye.
Bye.